Hello friends. So let us talk about the test specifications. So test specification is classified under your managing the test process. So first we're going to study about after studying about your different types of testing, different techniques of testing. Now the time has come to study the test plan, test configuration, test suite and so on. So test specification is entire part of test process. Now let us study one by one. First is your test management. So under the test management, we have test organization and structure of testing groups. So who are the people who are now before I actually explain you now the management will come, the management structure, who are the people, what are they doing, what are their jobs, or whom they are reporting, and so on. This I'm talking in a very simple way, in a simple language, so as you to understand the technical point, because the entire presentation is of technical terms, right? So after, as I explained in the first slide, after studying of testing techniques, testing types, now we are here to study about management, like test management. So first thing is, there are many ways, in many ways the test groups are organized, they are arranged, but there is no standard patterns. We don't have, like, IEEE has not given any kind of format that how the test groups are formed, what kind of, how many people should be there, who will do the, how many groups will do the unit testing, how many groups will do the acceptance testings, how many testers will go to the customer side and they will do the other acceptance kind of testing. So acceptance testing is further classified into alpha and beta, but that is different. Now we are not going to talk about any kind of testing currently. So what, how, when, how the work is arranged, how work will proceed, how they work ahead. Now, as I told you, see the acceptance testing group. So we have unit testing groups, we have integration testing groups. So now let's talk about acceptance testing group. Acceptance testing group is formed on demand basis, consisting of people from different background. They have a integration test engineer, system test engineer, customer support engineers, and marketing engineers. Normally, we see all any organization, if they have their own firm, own business, they have their marketing engineers to to show or to make their product, their company into, I mean, to bring into people's notice that we are software engineer, software testing company, we test this kind of products and so on, or the product application which is about to release, about to launch. Before that, if you have seen the advertisement, this application, that application, or any kind of hardware product or software product and so on. Okay, so acceptance test group is formed. Then how they form the group, how they form the people. Now they have different qualifications, different backgrounds. Okay, now they form, now the software development team or software tester team forms manager, software test manager forms integration test engineers differently, then unit testing group differently, or system tester later part. All these things, I mean, the entire system, the entire product is going to be test. So system test engineers, customer support engineers are about the troubleshooting in case of any help, in case of any uh, what should I say, any fault. Customer support helps us, then marketing engineers. Okay, now first it's about that integration testing group. Now integration testing group is about, simply integration testing is performed by integration test group. Now integration, we studied in the last session of how the integration was made, like from bottom up approach or top down approach. So different types of integration we studied. Now the time has come to implement this integration testing. Who will do this integration test group? They will integrate all these things together and they will perform the test. That means the system is sorry, integration is under test. So integrating testing requires a thorough knowledge of the module and the interface. If like I'm doing in C++, suppose like come to in a low think like you're making a C++ programming, that is so object oriented one. So you have a class A, class B, class C. Now you need to interface class B and class C. So by private or protect, you try to inherit this class. Okay, so that means your inherit means what? It is interfacing your class B and class C, right? So this is one program that you wrote like addition.c. This is a C. You wrote one program. There's another one, subtract.c, right? So now if I want to integrate this one module, one class, one another class, the third class, so all these class they should conform into the integration form. Okay, by how they are placed, like bottom up they are placed or top down they are placed. So accordingly I need to integrate, put them together and perform tests. So the modules are combined by following the system structure identified by the system design. So during testing, I have the documentation of a design or the implementation that how to do it. And before I do, I should have, I possess a thorough knowledge of the platform, the modules and the interfaces. That means as a tester, yes, you can say as a developer. No, developer is about the coding. Developer will not do any kind of testing, just unit test developer can do sometimes. But later part, the integration system, functional testing, stress testing, all those kinds of testing will be done by the testers. So the module which are combined by the software structures identified during the system design. So all these things, the documentation parts, the modules, their interfaces, their functions, is being identified during the design and uh, or during the implementations. So what happens is when they are under the test, by the looking at the documentation and thorough knowledge of working of these modules and the interfaces, they are going to put a test on them. So the leader of the integration test group reports to the software development manager. So they have a meeting, they have a review, how does the code works, what is the code about, and then the modules and interfaces comes in play. Then we have a system test group. Like the integration test group, we have a system. Now this is the entire system group. So the system test group is truly an independent group and usually has a separate headcount and budget. That means it has some number of people. It's like 20, 10, 20, 30, and it has their own budget, their own resource. So the manager of this group does not report to any hardware software development managers. No, they are independent and they personally they do it all kinds of testing, and they are all from the organization's level. So what happens is they understand, they ensure that the system requirements. Now again I will come to the term of system requirements, customer expectations, user satisfaction. See, these are the terms that evolved from software engineering, software design, software architecture, software testing. Number of ways we can encounter with this term. So don't get confused between your subjects. You have software engineering, software testing, software architecture. So don't get confused with all these terms, right? These terms they use it with all in different subjects because in the end we need customer expectations to be meet. To understand the customer requirements, we build, we develop, we taste, we first we study, we understand the requirements, we try to design, we try to architect them, then later we try to implement, that is to implementation language, later we put them on test. So now we are studying in a testing part so that we understand the user satisfaction, customer expectation and the requirements. So once here in the testing also the requirements is most important and that the system is acceptable. So this is all according to the customer requirements, and that what first is every testing group or every tester will make sure the requirements are met. They will go through the design, they will understand they will go through the coding, they will try to understand what the product is about, what the customer wants, and then still they will try to make sure that the system, whatever the system has been built till now, up till now, whatever the testing till now has been set by the requirements. So, in order to form a test group, now the crucial thing to form a test group, that is the size of the system test group. So, it is essentially, or importantly, this tells us the number of people should be performing the system level testing. So the size of the system test group impacts the delivered quality of the product. See, again, the same concept, that this tells us the number of people that will be performing a system. That means 4 to 5 or 10 to 12 people under a project. Suppose they are developing a notepad, enhanced notepad, which has colors now till now, and say notepad version, some what should we name them, notepad only, notepad enhanced version kind of. And this system group, once they understand ki, okay, this isn't about the notepad which already existed. Now what, why this has been built, because we have made certain things, like we have made a color palette, we have not we have made like a word format, word file. So we have little enhanced features. Okay, so system test group understand these things very well, and then they make sure that the delivered quality of the product, because at the customer side this should execute, they should work. Otherwise, if suppose if I'm working as a tester and in my environment it is executed, it's working very well, but when the time has come to show in the customer's place and it is not executing well, or what does, you only understand what does customer will say or what does customer will remark. So we need to understand that on both the environments with the same requirements it should execute the system requirements, or whatever the conditions. Since we are not talking about the requirements, we are just talking about the testing. So the size later, because every tester wants to ensure the quality of the product and the development cost of the product. But while developing, what happens is we almost forget about the deadline, because every tester follows a deadline, and deadline is one of the concept that it always bounces, because as a requirement changes, everything gets changed, including your testing test cases or test plan, everything. So, and the time to deliver the product, this is theoretically, this is very easy to understand or very easy to think, but practically when the changes occur, or when the time is running low, if we fall short because the risk factor comes, there is a change and so on. Then we have a later part, we have a quality assurance group. So in quality assurance group, a plant and systematic pattern. Okay, you understand what is quality. Currently, we mean quality is about uh, up till now what we have done, what work we are supposed to do. And the software quality, it assurance that a large part role is ensuring that conforms to the best development practice throughout the organization. So we understand how this works, how they tends to work. The Software Quality Assurance Group has sufficient authority, power, standing to work with entire organization in defining process, dictating peers to follow the process. Now, what happens is how they do it. The first thing, they always compelled with the technical requirements. The very first thing. Then a set of activities, the all set of activities about the phases, the life cycle to evaluate the process, because after evaluation, during the evaluation of the phases, or during the phase itself, the life cycle of the product, these activities, the quality assurance activity is still carried out. And let me tell you, in the software engineering, that each, not software engineering, but everywhere, in every field, starting from your forget about your requirements, but from your designing to your implementing to your testing and maintenance, in the end, the quality assurance groups takes place. I mean, they come into the picture, they make sure that they validate your requirements, they check your requirements, and later part we go through the next phase. We go to the next phase, not through, but we go to the next phase. That means this implies that the software quality assurance group has a larger role in ensuring the conformance to the best development practice, because we'll study the later part about the quality factors. The quality factors have been divided into certain values, which we ensure that these values against the product and ensure that okay, this is about reliability, safety, and so on. My product is reliable. My product is has a safe measures. My product is easy to install, portable, and so on. So if these kind of features, if these kind of values are assessed by the software quality, so all the customers can happily buy it. So later the marketing marketing team enjoys like okay, we don't need to market these things, we need to buy this product. This is very easy because the first thing we want is portability, we want economic to be less, the cost or budget, of course we check our pockets. It's this is the product we need to buy. Yes, if the cost is less, we can afford. So this quality, we are not talking about how to purchase and all, but yes, the software quality plays a role and dictating peers. The software quality assurance team should have a sufficient members to do a thorough and professional job. Yes, see, in the end, everyone's are appointed as a professional job doing. So that means a professional should understand how to do it, what to do it, and in the end is about the quality. Okay, so I hope this is very clear to you. Now, the quality management group. So, this quality control and quality assurance. So, according to IEEE, is defined in the IEEE as a set of activities which is designed to evaluate the quality of developed or manufactures. So, the term is used in the production or hardware. So, this term which we use is in the production or this is in the hardware. But the term which is used normally what happens is like suppose if I want to buy this pen, I hope I gave you this example, like when you go in the market and when you ask the shopkeeper for a pen, why do you open the cover and write on the paper? Why do you want to test it? Do you trust your customer shopkeeper that the shopkeeper will give you a good quality pen? Is this a good how will I rate this as a good quality? Can you tell me? I'm showing this pen. Can anyone tell me? Okay, we want is according to my requirements. My requirements, that means my pen should write, the nib should write very smoothly, the first thing. Then second thing, it should not stuck between, the ink should not leak, and it should be like easy to, I mean gripping should be very easy in a comfortable zone because I have to write lots of things. So these are my requirements that are set up during buying a pen. So see, this is a small example which I give you. So how you rate the quality, how you understand by the quality. This okay, this control, that means it evaluate the quality and developed for the manufactured products. Later, we have system test team hierarchy. Okay, now let's talk about the system test team. So, how many members and what are the groups? How many groups are there divided? What are their roles? They play their role efficiently? No, we are not here to judge the roles to play efficiently. But what are the roles? What posts they hold and so on. So, first thing is subgroup with more than 12 members. So if the subgroup consists of more than 12 members, they will be divided into two subgroups for better management. Like two subgroups has 12 members. Then members of the subgroups include. So what they include is technical leaders, principal engineers, senior engineers, and junior engineer, and their roles and responsibility is been defined clearly. Then the test managers. So test manager is a key person who is in charge of all aspects of the assigned testing task. Now, suppose junior engineer is assigned the task about test cases. Okay, test cases you won't understand now. Okay, you must have read in software engineering. Okay, but we'll not get into it. Suppose if they say fine, then junior engineer is responsible for testing like unit test or system test kind of. For example, we am talking about. Senior engineer is to verify and evaluate that whatever the junior engineer results, output, outcomes have been defined, access again and reevaluate again, or say they're going to perform a system engineer, only junior engineers are here for unit testing. We are just dividing the roles, and but each and every group is been assessed to evaluate the quality. Now, the manager leads the group by working with other test groups to perform testing functions. See, again, the same thing. That means to evaluate, to assess, to evaluate for the good quality, the high quality products are released. Later, if we release without ensuring about the quality, my customer will come to me and will give me adverse remarks. So I don't want this kind to be happen, or this I don't want this thing to happen. So what should I do? It's like every in the end every small codes or small functions, small modules is being assessed, is being tested, is being evaluated. How, when, we'll see. These things are coming. First you need to understand the basic thing, like who will do, how will do, what they will do, we're going to study in a later part. Then we have the technical responsibility of the test manager. That means the test manager will include developing a test plan. Test plan is the basic concept. It's like how you define your SRS. So you defined your SRS by some it's like scope, starting from the scope, then the existing market survey, that means literature survey, then you do some kind of your experiments, you put your results, then you start working on it, about your you write about your implementation plan, your hardware requirements, your software requirements, and so on. And later you try to take the snapshots, or you try to put your models, you just write about, or you create about making, how the models are worked, how they models behave. You write, you draw the UML diagram, you try to define the structure and the behavior patterns of your models, how they are interface, and so on. So how you define your, I mean, this is low, I mean, very simple words I've used for SRS. There are technical words which you define and you write your own SRS during your project work, mini project, or a final year project. So that means the same way we develop a test plan. So test plans includes the name of the person who is going to do entry plan, exit plans, number of I mean, what kind, who will do the testing, what type of testing, and what kind of, I mean, what modules to be tested, and so on. I mean, it goes and on. So it's executing a test plan and handling the crisis. See, the crisis comes in every stage, in every phases, or in every activities. Maybe it's a software quality activities, or in a life cycle model or test cycle model, everywhere. So developing, following, and improving the test process. The first is developing the test plan, and handling the crisis is like the short of resources, short of people, but as I said, resources. So it comes under your people, it comes under your time, your machines, and so on, your software. All these are management terms. Your license copy has expired, you need to renew it, you need to work on your software, your company should purchase that software, and so on. So these are the crises, these are just few crises, but there could be a lots of things that can be mentioned. Then defining, collecting, and analyzing metrics. So every time that if the changes come, or every time if the error is found during the testing, that the system is not met according to the customer requirements, even though the metrics is collected, it is still measured. It's measured, and it will give you some remark, like not any negative remark, but it will give you the quality, not good quality. And what are the good qualities or bad qualities not mentioned in a software, but it will not compare with like other values. What are the values, we'll see in the next topic. But first we'll need to come define this. So that means second is developing, they need to develop, follow, and improve the test process. Because see, what happens is when a beginner joins, or whenever the beginner works in a company, and first he or she wants to get an experience. And after setting, I mean, few months of working, when he or she is comfortable, then he or she starts working on it, comfortably he or she starts working. So that means some kinds of, like, as I said, improving. So he or she can focus the work, and every time they can, the test process gets improved. Okay. Now next is about again the system test hierarchy. That means the test management. The test management acts as a nodal point between the upper management, your project management, quality management, and the marketing people. So that means the upper management, project management, the project manager, one who looks after the project. Upper management is the management and all, quality management team, and the marketing people. So junior engineer are the new inexperienced test engineers are put as a at the junior level, and they gain experience by working by assessing the senior or the principal engineers in the charge of test execution, setting up the test beds, and developing the scripts for the test automations. Then we have they design up the test laboratories and environment. Senior engineers assist software developers in producing the defects. They participate in the test plan, review meeting, and support maintenance of the test laboratories, automated test suites, and the test tools. So here they have mentioned about the junior engineers, like who are these people and how they work with, how they try to get an experience. So maybe they are interns, if I can say, because they work first and foremost. They assist the senior and the principal engineers, then they start working, looking, setting up the test beds, and they write or generate the test scripts and so on. Then test engineers. So test engineer, senior engineers are they design, develop, and the execute test cases. So they mostly work with the test cases. Now, they design and they set up the laboratory environment. Senior engineers, they also assist software development, reproducing known as defect. Now they also need to work with the defects. So certain defects, if they found during testing and they are not resolving, what senior engineer will do? Senior engineer will consult with the developer. He or she will sit with the developer. They will talk with the developer, negotiate up, and helps to resolve this defect, right? So they participate in the test plan, review meeting, support, maintenance of the test laboratories, automated test suite, and the test tools. Next, they have now next is about the principal engineers. So the principal engineers are the test specialists. They are responsible for the test planning. They are responsible for the test automation, test environment planning, test tool development, and performance modeling, reliability engineering, and business except tool. Then we have a technical leaders. Now, who are the technical leaders? That at this level, the engineers should have a technical testing skill of a principal engineer, as well as negotiation skill, process and project management skill, and communication skill. That means a technical leader should possess a good communication skill, a thorough knowledge in what they are working on, and they should coordinate with many engineers working with difficult or a complex project. See, the project is not a project is not just this and this boundaries. These just we are talking or we are explaining in theoretically. I'm just explaining about these two boundaries only. But if you go in reality and you just see, it's a very complex, it's a very vast project. Next is test planning and the design. So now we are here for test planning and the design one. So the purpose of the system test planning or simply test planning is to get ready and organized for the test execution. So in the end, we want the test execution result. So in the end, we want text execution or customers requirements to be satisfied, or its user expectations to meet. So a test plan, it provides you a framework. It provides you a scope, what to test, then a detail of resource needed, what kind of resource you required, then efforts, that means how many people will be involved, how many of them will do their job in this kind of testing, particular testing. So if I say unit test people, 5 unit test people, 10 system testing people, and so on. Schedule of the activities, like deadline, and the budget, like how much budget, the cost of this test, how much I have to require, because I need to ask from the management, the company's management or the firm, because I need to I need to have my proper software. I need to have my license copy software to test all these things. Then during the test design phase, now the test is also like test design phase, test execution phase. So don't get confused with all these terms. Make clear, note down all these definitions one by one so that you will have a clear understanding what is test design, what is test plan, test executions, and so on. So the system requirements are studied. So system feature which is to be tested are identified, and the objective of test cases and detailed behavior of test cases are defined. Now test cases is it's covers under your test plan. So test cases, it has first it has like modules, name of the module which is to be tested, then um type of the testing use, in the inputs whatever that you have inputted in the modules, then you have a type actual value, expected value or actual value, and then remark, pass or fail or satisfied or non-satisfied. See, the test cases is are in a compatible manner. That means accordingly you can build. But IEEE 830 829 has given us the test cases definitions, right? So how to provide, how to write the test cases? Then each test case is designed as a combination of modular test components called test steps. So first steps, that means a combination of your modular test. The test steps can be combined together to create more complex or multi-step test. That means it is clearly defined that other can easily borrow, understand, and reuse. How that other will borrow and reuse? Because see, if the test cases, my concept are same. I mean, the requirements, the partial requirements are same. So the test case can be easily borrowed. They can easily be reuse it. Then we have another one like in test driven development. The programmers design and implement test cases before the production code is written. So the programmer design and implement, like in test driven, the test cases are planned, that what types of testing to be performed on the modules, what are the how many modules are to be picked up during the test cases. Then the main characteristics, now this is about the agile. So in agile what happens is it is done in an incremental development. The coding of unit and acceptance tests conducted by the programmers along with the customer, then frequency of regression testing. So if no, why should the if? Whenever the changes come, the regression testing has to occur, because these changes are then these changes are accommodated, they are tested, and again they are evaluated. So writing test code one case after the before the production code. Next is your test case specification. So, using the test plans, the testing team designs test case specification which then combines the basis for individual test cases. That means we need to first that during the test plan. Now we are still in the test plan. We have not moved ahead because in the test plan the test cases are preferred. So the testing team will put the test case specification, that how many peoples will require what module, which module, the entry points, exit points, and so on. So test case specification should clearly identify, or they should have a clearly overview what is about the test cases. Oh, who is going to write? And how many? I mean, test cases are never ending process. They are just, in fact, if the changes occur, again we have to write. So the purpose of the test, why we need to test. These things, what the mention here is test case specification. That means these are the concepts of the test cases. Items to be tested along with the version release numbers are suitable. So it's like it's already in a version 1. Now it's in a version 2. Again, they are in tested. What happens is if the product is released in a second version form, so some of the test cases can be repeated. So we can still test cases from there. Then input data to be used for the test cases. As I explained you, the inputted data, that means a module which is put on the which we are putting on test, and what are the inputs to that module is being tested, so that we can verify this is according to the customer expectations, according to the customer needs, and so on. So these steps to be followed and to execute the test. Now, I don't know, in your final year, have you ever you will write your test cases. Is this test cases included in your final year? I don't know. But normally you will start with your login. If you build up the login form, you will start with the login. First, you will give the correct values. Then you will give the incorrect values. Even if you give the incorrect values and your system accepts that, that means you are not according to the customer requirements. No matter what, if the wrong input is given to the login credential, it should not work. This should be very clear. So even though even though your test cases should give you that if a test case is negative, but your system, the login form will not be able to open, then the expected result that are considered to be the correct results. Now, here in the test cases, we try to match the expected outputs or the expected result with the actual result. If the expected says fail and the actual says it has passed, that means why this is contradictory. If my actual says fail and expected says fail, it's okay. I understand. And again, the if actual and expected says pass, I understand. But if actual says fail and expected says pass, again there is a contradictory. So always try to work with small details, because small things matters much. Later, a step to compare the actual result produced with the expected result. This is the comparison, and this comparison helps you to understand whether your system is built according to the customer or not. Then we have next is testing metrics for monitoring and controlling the testing process. That means the metrics for monitoring and test executions. The first kind of metrics concern the process of execution, the test cases. The metrics for monitoring defects. So we have the concept like text execution. The first thing considered about the concerns the process of executing the test cases. Then we have the monitoring defects. This is a second kind concern that defects found as a result of the text executions. Correct. The first thing is about what I was talking about, the test cases. Later, during the text execution, if the defects found, so that means if your expected and actual results are not matching, so that means there is some defect and you need to find those defects. So later we are in the test monitor. So what is the test monitor? The test monitor framework must consist of exhaustive steps and specific targets required to correlate and the current status of test work products and tasks to the plan and strategic objective. I think this is quite difficult for you to understand. So this is a definition which has been given, that a test monitoring framework must consist of exhaustive steps. They are defined with the number of steps and specific targets. That means it required to correlate the current state of work, my test products, and which I have planned, the task which is I have planned after finishing, and the what is my objective, the strategic objectives. So is a framework. What the current status work, what is my status of my work, what are my plans, what are my next plans and strategic objective. So comparing the current status of the test work products and the tasks against the plan and the strategic objectives. So that means again the test monitoring is again it's like a plan. It's against the documentations about your test work products, about your small tasks, because each and every task is broken into the subtask. So against the plan, it should be against, not against, it should be according to the plan and the objective. But as I said, it's against the plan and not a plan. We make a plan, we make a documentation, planning documentation, and so on. But normally, what happens in a reality, it goes what we planned. Either we fail with the resources, some risk encounters, we fall short of deadlines, or we fall short of resources, or the employees, and so on. Then, the other projects are more detailed objective must be defined to accomplish this. So, target and measures that are needed to achieve the objective of the test and test basis coverage can be included in this. So, mostly the test objectives. You will ask me what is a test plan and test objective. Both are different. Test plan is like who is doing how, oh, what are the scope of testing, input and output, date, who will going to do it, how many people are there, what is the test start date, test end date, and so on. It's a complete documentations. But test plan and later the test objective, detailed objective must define to accomplish this. Targets and the measures are needed to achieve the objectives of test and test basis coverage. So we need test monitor. It itself is a different thing. So it's important to map the test basis of the status of activities. That means for each and every activities like my unit test, my integration system, and so I have to understand. I need to go according to the plan and to map the test basis and to relate the work products. So it is easy to understand, logical, and apt for the business stakeholders as well as for the project. So this is about the people, about the to understand how they work, how these things are worked. So that means it clearly mentioned the outlining of the goal and assessing progress against a predefined set of conditions. So what we make is we make a plan and we try to map this with the current work. We try to map with the existence, work exists. What is the status of the work? How much the work we have completed? How much is left? Are we according to the framework or not? So next is, as we recognize a complex correlation between the work products of testing and those of the development and test spaces. Now currently we are correlating with the exist existence between the work products of the testing and with the development and test basis. So this complexity is currently reduced by structural traceability, and we incorporate the capabilities to report accurately on the status of traceability in the design. This can be something to you might feel this is kind of difficult one, but try to understand that this we are mapping with the currently what the work we are doing. So what we did in the planning stage, in the planning stage, it is natural to estimate the cost of the test. If I if I budgeted my cost, that my cost should be at least uh, 1 lakh. Suppose this should the expenses should be till 1 lakh, but in the end of the testing, in the end of test metrics and so on, the for monitoring and control, test monitor, test beds, when I'm in the middle of the testing, I'm seeing my expenses still growing up. That means it grew up by again say 10%. So this means the budget is still not fixed. I have made expenditure of the budget, but the budget is still increasing, right? Because my deadline is crossed, I need resources, I need the peoples, because my since the change has accommodated, the project has grown a very big, it's a complex one. These types of things they always inculcate. You never just behave like, oh, I finished doing. No, there's never, it's ongoing process, a continuous improvement process. In the planning stage, it is natural to estimate the cost of testing and the time to complete the test. Together, the test parameters like cost and times are called test effort. That means your test efforts always increases or decreases. The cost increases, your time increases. But it never happens the cost decreases and time decreases. Never. Then the key factors. you will also face this when you will do your final year project. How many times your requirements has changed? Because when you think about you're working, when you just think about your requirements, like, yes, I will do this module, I will work in, suppose, PHP, but PHP under this, suppose you're developing module A, but your module A is not working on PHP, you will give up. You will say, okay, I'll do in HTML5. That means my implementation language has changed according to my requirements, also change. So certain things I will remove, certain things I will add according to the platform which I choose. Because this is runtime, the scope is very small, it's very limited. But actual, when you see the developing life cycle, when you just see testing life cycle, the scope is huge. But you need to define the boundaries. You need to stop somewhere. Otherwise, it's just ongoing process. It's going on and on. Okay, so now the estimating the test effort. So we have three key factors. The first is number of test cases to be designed for the software project. So number of test cases, if I say currently is 50, but later again, as I said, the changes, the ongoing process, the regressions, and so on. So it will move to at least 100. So anytime it can change. Then effort required creating a detailed test cases. Yes, this the test cases I created is a very short form, but when I worked on the detailed one, when I took one module, when I performed different types of, if suppose they have performed different types of tests, and what could be my outputs, my inputted values and outputs, and so on. So efforts required executing a test case and analyzing the result of test execution is a very hard work. Then you have a estimation model for the test process. So now we have come to a stage where we need to estimate ourselves, not about our testing process. That means up till now we have studied a test plan, test scopes, test monitor, test cases. So now we time has come to model for the to make a estimation model. How will you estimate, how will you create budget for your test process? So what we defined earlier was the same thing. Then you have a estimation based on a test group category. Means again, what we saw in the last slide was a test process. But now the estimation based on the test group category. So we have, it's a straightforward to estimate the number of test cases after a test suite structure and the test objectives are created. So the test suite. So what actually you mean by the test suite? So it's a container. So that has a set of tests which helps a test in executing and reporting the test execution status. So that means a test. So if I say a test plan is a document that defines your scope, your objective or strategy of testing, but your test suite is a prepared for the test suite is test plan, working of test plan. Test suite contains the collections of your test cases, like test cases A, test cases B, test cases C, the number of test cases you have. So it contains your test cases inside it. Then this suite it also includes a number of tests. How many tests have been performed or how many tests you will perform and the test cases. So I hope till now, sorry, I hope you have understood the work of your test suite structure. Now we'll see about the number of test cases used by the end of system. Test phases is more than initial estimations. So a more accurate estimations of the number of test cases for each group is obtained by adding a fudge factor by 10 to 15% of the total groups of test objectives identified for the group. That means the number of test cases used at the end of the system phase is more that it's more than its initial estimation. As I say, estimation changes. It changes for what you have planned before, what will happen after. So now will talk about estimation based on the function points. So what are your function points? How will you define your function points? So the concept of function points is to estimate the resources by analyzing a requirement documents. That means a central idea is the function point method is given below. That means it has a functional view of a system in the form of number of users, inputs, user outputs, online queries, number of logical files, and external files. So all these things, lines of code, there are two things. One is function points and one is line of code. Normally have studied in your developing thing in a developing life cycle, that how your software is estimated, but how your testing software, I mean testers, under certain circumstances, under the testing conditions, how they are estimated. So this estimated will reflect your cost. So on what parameters they are dependent? They are dependent on the user outputs, the user inputs, number of user inputs, the number of user outputs, then online queries, number of logical files, number of external interfaces. One can estimate the project size in number of lines of code required to implement the system and number of test cases required to test the system. See, what I have explained the earlier part, it's making a abbreviated form. So NR starts for the number of external inputs, NO starts for number of external outputs, NQ starts of external inquiry types, NF starts for logical internal file types, and external interface file types is any. External interface is any. So the four steps for computing a function points are described below. So we first say identify the user. See, this is not a user model or user actor model. This is not an interfacing thing. But how you define your estimation, on what basis the estimation is this software, this testing software is estimated. The first thing is identify the five type of your components, also known as user. Second, analyze the complexity for each of the above five types of user function and classify into three levels, namely simple, average, or complex. So, user function classified into three levels of complexity. Now, again, we are in the terms of complexity. This complexity words you have understood in your algorithm, because you try to measure the complexity of the system, you try to measure the complexity of the algorithms. So same way, a weighing factor which is associated with this level for complexity for user type of functions. So this have through this there is we estimate, the estimation is based on their function points. So right now, what was the abbreviated? The abbreviated which we used, the NI was the input types, then NO was number of user outputs, external inquiries was NQ, and so on. So WF is your external input, NI, and WFNO is your external output. So external is your WF. So now you try to define your function point, which is unadjusted or very crude function points. So with these factors, with the weighing factors, along with the components, they are multiplied and all of them are summed together. With the summation of this, you will get your UFP. So you will get your estimated of based on your function points. But again, these are not, still we have not stopped yet, we have to still work on. This is just the beginning. So that means it is an indirect method and direct method. So there are two types to define. So again, what are the two ways? We'll see. The code size from the function points and the estimates the number of test cases from the code size. So how will you calculate the code size with the line of code? The entire code. Suppose this code is of full A4 size, both pages. So how many lines? So you have to identify how many lines you have been coded, or the product is how many lines. Of course, it will be about 1,000 kilos, anything, not kilos, but thousand, like KLOC, thousands line of code. Okay, we move ahead. So again now, as I was talking about LOC, now here it's the LOC does not mean line of control. We are talking in a software testing terms, and we mean LOC as line of code, right? So line of code is always given in the task, in the downside your task bar defines you how much you have written it. Even if you have written in Linux, the code is written in Linux or in a Windows, any application which implementation language which has been used, in the end it's written that how many lines you have been used. So the function points of the software systems are computed by examining the details of the requirement of the system from the requirement database. So this implementation of the system is in a different programming language will produce different measure lines of code. Of course, as I said, if you do in if if I talk about your operating system, maybe it's Windows, is a Linux, or in a different application software. So we mentioned here different programming language will produce different measure lines of code. So one programming language, suppose C, will give me thousands. Otherwise, Visual Basic will give me some hundreds, for example. Maybe with certain things which are required to expand, which are required to contract. Maybe this can happen. Then, given the total number of function points, earlier we studied the function point for a system, and we can predict the number of LOC by making an assumption of a programming language and an implementation language. So we need to understand we need to utilize the user's experience in estimating the number of test cases. So direct method is about function total number of test cases is equal to function points into multiply into 1.2. So the number of test cases estimated above, it encompasses all kinds of a testing done on a software system. So that means all types of testing, like testing technique we have studied. So we begin with unit testing. Okay. Earlier we begin with black box testing, then white box testing. Later, these were the techniques. And what were the types? We studied with unit testing, integration testing, system testing, regression testing, acceptance testing, and so on, right? So we have to follow this. We have to follow with the test cases. We have made the test cases using this kind of testing, and later we defined our function points. So it does not distinguish system size from the total testing effort. Then we have a test creation efforts. That means who is going to do it. Test case creation efforts like size and the time, cost. The cost and the time is a test effort, but what is a test creation effort? That means reading and understanding the system requirements and functional specification of documents. The first, creating the test cases, entering all the mandatory field including test steps, pass and fails criteria. So currently we are studying the efforts to make during your made during your test cases. So test cases is not an easy job. First, we need to understand the test case documentation. So we need to understand the system requirements before we go for a test. Then we create a test cases. When we create a test cases, we include all kind of test testing types. What we're going to do, and we're going to write about the inputs and outputs. We're going to write about the inputs, then we'll compare with the actual and expected outputs, and then we'll remark which pass or fail. So accordingly, this test cases creates your estimations or your budget. So again, the skill and the effectiveness of a test engineer, there are significant factors which influences your test estimation of your test case creation. So everything has estimations from the beginning till end. Then test case execution effort is, so in any case, one must consider the following factors in order to estimate the work effort by manual test execution. This was a manual we make, but how you make automate, since there are certain software that are available to automate your test cases, like understanding the test cases if the test cases have not been created by the executor or by the uh, nobody has created a test cases, but by looking at it I can figure out, by looking at the code I can figure out what could be the test cases, because sometimes the one who makes the test cases have the efficient understanding, efficient knowledge to frame it from instantly or immediately. So configuring the test beds and executing the test steps and evaluating your test steps. Correct. Now, your execution, your test execution status, like it's pass or fail for the test cases. Then the logging of your test results from your test factory database. Now, we have a test case database and we pick up our test cases from the test case database. So collecting and then analyzing the data if performance and stress load test cases have been executed. Then updating the test cases, again they are stored in a test factory or test case database. So in this way, we understand about the test case effort. So every, like from test plan is estimated, test case estimated, your each and every test itself independently carrying your testing is estimated. So, in the last, we are about to end. Okay, in the event of the failure, what are the performing are the following tasks, like try to reproduce the failure, executing different scenarios related to the failures observed. Then we have like what made it to fail. We have a configurations logging of the system hardware configuration from where it has failed, because even the configuration still changes, your application should work properly. So the testing, so in fact, what the implementation has suggested in the hardware requirements, as a tester, I have changed the hardware requirements. That means I have, even if I have not changed it. I mean, I have implemented my code, or I'm executing my code with different hardware configuration to change. Even though if there is a change in hardware configuration, will this product affect? So again, if it is affecting, so then there is a defect caused, and filling a defect report is a defect tracking system. So again, the defect life cycle goes on. So if a software developer cannot reproduce a failure, following up with debugging and localizing the problem. So here I end with my testing execution or estimating the test efforts. So I hope you have understood and revised thoroughly.